About a year ago, Engenius made the decision to divide its access point line, leaving the ACW series for enterprise-level users, while the FIT line was supposed to cater to the home or at the very most, the small businesses. It seems that this approach paid off and Engenius released several models, including the newer FIT6 4x4 Lite, also known as the EWS276-FIT, which, as its name suggests, seems to be a stripped version of the FIT6 4x4. But how light is it actually? Both access points are Wi-Fi 6 and there is support for FDMA, and yes, both of them offer 4x4 spatial streams on the 5 GHz and on the 2.4 GHz radios. One notable difference is the 5 dBi antenna of the FIT6 Lite as compared to the 6 dBi of the FIT6 model, and it also seems that the former does not support the mesh technology. It is a very curious decision, so perhaps it is hardware related. Other than that, there's a 2.5 gigabit port, there's both local and cloud-based management using the FIT controller and the FitXpress, which for now are completely free. So let's first have a closer look at the design of this device. Engenius has done a fine job at differentiating its access points from the other brands. When you see that slim rectangular case, you know it's from Engenius, kind of like the flying saucer style of the Ubiquiti access points. And yes, the FIT6 Lite is fairly compact, having the same size as the FIT6 4x4, but it's a bit smaller than the Wi-Fi 7 ACW536. The top is made of plastic, while the bottom section is metallic and does have the same area for adding the mounting bracket or to simply use a couple of screws to hang the access point to the wall. We continue to get a series of LEDs, which is excellent, and we can see if the FIT6 Lite is powered, if you connect an Ethernet cable, and if the two radios are enabled. Moving back to the rear side, there is a carved-in area where you can find a recessed reset button, the 2.5 gigabit PoE port, and a 12-volt DC power port. So unlike the Ubiquiti access points, we do get the option to not rely on PoE. The bottom side of the access point is essentially one big heatsink, so yes, it does have the potential to get hot. But does it happen? It didn't during my tests, but then again all is fine as long as the heat is being pushed out and away from the internal components. Furthermore, the device did not show any signs of throttling, so that's good news. Engenius makes it very simple to access the inside of their devices, which is always appreciated. So, to open up the FIT6 Lite, remove the 4 screws from the bottom side and then use a prying tool to take out the plastic top piece. You will also have to remove the antennas, and luckily none were soldered to the board, and after taking out a couple of screws we can finally get access to the whole PCB. I already went through the teardown process in a dedicated video, so I simply added the main components here. There is also a comparison table to get a good idea how the EWS276-FIT compares to the other access points. I have mentioned the support for FDMA, which will help reduce the latency in a crowded environment, and yes, MuMaIMO is also supported even though its impact is somewhat less impressive. But what caught my eye is the lack of support for the mesh technology. Sure, it had to be proprietary to the FIT series as no brand wants to deal with devices outside their walled garden, but why hasn't Engenius add support for it? I honestly have no clue. Probably because they thought the system would get too complicated, or maybe they're still working on the feature, I don't know. Lastly, I do need to mention that the access point has support for up to 80 MHz channel bandwidth. It does not go wider than that. Now let's have a look at the single client tests, and I used one Wi-Fi 6 computer equipped with an Intel AX200 adapter, one Wi-Fi 5 device equipped with an Intel 8265, and lastly an older Pixel 2 XL. And we can see that the FIT6 Lite did well, especially in regards to the Wi-Fi 6 client device. That is both upstream and downstream. When compared to other access points, it's not at the top, but it does solidly stay between the ACW536 and the ACW230S. As for range, it's not phenomenal, but when the signal attenuation was close to -80 dB, we could still use the internet, although in a fairly limited fashion. It's worth mentioning that the Pixel 2 XL disconnected at that point, so bear in mind that some older Wi-Fi 5 devices may require to be closer to the access point. Lastly, let's have a look at the long-term performance of the FIT6 Lite. Afterwards, I checked out the 2.4 GHz radio band performance, and after making sure that the network was set to the 40 MHz channel bandwidth, the results are more than decent. Even when the signal attenuation was at about -70 dB, which I registered at 70 feet, we still get usable throughput, in some cases close to 100 megabits per second. When compared to other access points, the FIT6 Lite falls in between the ACW336 and the Ubiquiti U6 Pro. The single client test will almost always show big numbers, but we are more interested in how the FIT6 Lite deals with latency when more than one client devices are connected, each demanding a piece of the bandwidth. I use the same set of devices as before, and this is the signal attenuation for each of them. Additionally, the measuring tools are the open source suite from NetHydra developed by Mr. Jim Salter. And in the first test, we check how the access point handles 1080p streaming. We see that one client acting up again, so we are going to ignore its performance. I promise I will change it soon. But overall, the Wi-Fi 6 and 6E clients did really well, staying below 50 milliseconds for at least 95% of the time. The Wi-Fi 5 clients had a harder time, but I suppose staying below 80 milliseconds for 95% of the time is still decent performance. Moving forward, I checked the 4K streaming on 5 clients, and the Wi-Fi 5 clients went above 100 milliseconds immediately, so we can discard them. The Wi-Fi 6 and 6E clients stayed near 70 milliseconds for 75% of the time, and then slowly going close and above 100 milliseconds, nearing the 99% mark. This means that you will not have a great time if you intend to run the same type of traffic, so it's best to limit the number of devices. Afterwards, I added intense browsing traffic, which simulates a somewhat more frenzied internet search, and I ran it alongside the 1080p streaming on all 5 clients. There is definitely an impact, but not as much as I expected, and pretty much all devices stayed below 100 milliseconds for 95% of the time. The intense browsing graph shows that 2 clients did go near 1 second, while all other remained below 300 milliseconds for the entire duration of the tests. Then again, I think most people will reload the page after at least 1.5 seconds, so I suppose all is good. Next, I ran the intense browsing traffic alongside 4K streaming on all 5 client devices. We again see an impact on the latency, with the 2 Wi-Fi 5 clients remaining unreliable, but I suppose the other 3 remained near or beneath 100 milliseconds for 95% of the time. The user will see some buffering in the videos. The intense browsing graph shows that 4 clients did really well, while that one device, which always acts up, went above 1 second. Now it's time to change things a bit and run a mix of download, 4K streaming and intense browsing on 5 client devices. The first test involved 2 downloading clients, and you can see that both went above 300 milliseconds immediately and at 600 milliseconds at the 99% mark. The intense browsing client stayed well below 400 milliseconds, and the 4K streaming client went above 200 milliseconds immediately, so I could hardly call this test successful. The total throughput that I measured was 448.5 megabits per second. Moving forward, I limited the downloaded traffic to one client, and it did a bit better, although 200 plus milliseconds is nothing to brag about. The 2 intense browsing clients remained within the acceptable boundaries, while the 2 4K stream client devices struggled quite a bit, going above 100 milliseconds and way beyond. The total throughput was 372.7 megabits per second. I figured I could limit the number of clients to 3, and the latency was better, but I'm fairly sure that it's still well below acceptable levels. The 4K streaming was also far from ideal, while the intense browsing did well. The total throughput was 186.1 megabits per second. I changed things again and downloaded a 1 megabyte file this time, while one client handled intense browsing and another the voice over IP traffic. We finally see a decent latency at the downloading client level, while the voice over IP latency was also better than expected. Lastly, I ran the downloading traffic on the 5 client devices, and these are the results. The total throughput was 332.9 megabits per second. Unlike the ACW series, the FIT line does have a comprehensive local management platform which does not require access to the cloud. You can use a cloud controller if you want, but you don't have to. The local platform has some status info presented underneath the overview, while under network we get to choose how the access point gets its IP address, and you also get some freedom into creating and managing the wireless networks. Be aware that by default no security is applied to the single SSID, so it's wise to click on Edit near the SSID name and set a strong passkey underneath the wireless security tab. We can see here that we get a solid amount of options to adjust, including the support for fast roaming, which is excellent. The management tab lets you change the SNMP settings and the way to access the device. Make sure to disable the telnet access. We also get some very nice tools, but that's about all, so let's check out the cloud management platform. The Engenius FIT6 Lite can use the FitXpress platform, and after creating an account, a new network, and adding the device, I gained access to the interface. And it's a very simple and straightforward layout. The dashboard showing some status info, while under devices we can access the FIT6 Lite dedicated settings. We can see the Engenius Cloud pedigree here as well when accessing the tools section. Under Wi-Fi there are 2 default networks, and again it's wise to personalize the settings and add a proper solid passkey. There is also portal templates, application control, scheduling, and all that's needed to run a small business network. By small it can also mean simple and not complicated, so it is a scalable solution. You will see at the bottom what is called a Fit controller, and it does work in a similar fashion to the Unify and the Omeda local instances. But there is one major difference, and is that you can't run it on your own hardware, which requires a dedicated device from Engenius. The Fit line was a very risky bet from Engenius, but it seems that it may have paid off, because home users and SMBs didn't really need all those extra features, which obviously came at a very elevated cost. A device such as the FIT6 Lite will be more suitable for them since it's designed to be user-friendly, but while still supporting the means to remotely monitor and configure multiple devices on different sites. The hardware is alright, the software is good, and the performance is acceptable, just be aware that it does have some quirks. That's all for now. Don't forget to subscribe and like if you want similar content in the future. Thank you for watching and see you next time.